Okay, so our next topic is combination. The meaning of this word combination is selection. So here our first formula will be the number of combination of n distinct object. Now this distinct word is very important. We can apply this formula only when all the objects are distinct. So the number of combination of n distinct object taken r at a time, this will be given by the formula NCR, and this NCR will be nothing but factorial n by factorial r into factorial n minus r. So this will be the formula for NCR. Now with the help of one example, we'll see how to apply this formula and when to apply this formula. So suppose if I have a question that there are 6 non-collinear points, 6 non-collinear points. The meaning of this word non-collinear is if a number of points are not in the same line, then those points are called non-collinear. For example, suppose if I have say these 3 points, then these 3 points A, B, C are in the same line and therefore these are collinear points. Okay, so the question is there are 6 non-collinear points in a plane. There are 6 non-collinear points in a plane. Find number of triangles that can be formed. Find number of triangles that can be formed using these 6 points. Okay, so this is the question that we have. There are 6 non-collinear points in a plane. Find the number of triangles that can be formed using these 6 points. So first let me plot those points. So I'm going to draw a circle, because we know that on a circle no 3 point is collinear. Now on this circle we are going to take 6 points. So say these are my points A, B, C, D, E, F. So these are the 6 points that we have. Now the question is, by joining these points, how many different triangles are possible? So see here, if I select any 3 points, suppose if I select say point A, C, F, then I will get one triangle. And here the order in which we are doing the selection is not important. Whether we select point A, C, F or we select point C, F, A, we will get the same triangle. So here we have to simply select 3 out of these 6 points, and corresponding to each selection we will get one triangle. So for this particular problem, the number of triangles here will be, we have to select 3 out of 6 points. So this means this will be simply 6C3. 6C3 is number of ways of selecting 3 out of 6. Now using the formula that we have just seen, 6C3 will be factorial 6 by factorial 3 into factorial 6 minus 3. Now if you do the calculation, you will find that this number will be 20. So this means total 20 triangles are possible by using 6 non-collinear points in a plane. Now see here why we are doing the selection and why we are using C and not P. So the reason is that in case of permutation, one of the basic difference between permutation and combination is, in case of permutation, order is important. In case of permutation, order is important, in which meaning that the order in which we are doing the selection, that is important. For example, suppose if I have a, say, if I had to form, say these 6 letters were given A, B, C, D, E, F, and the question was we had to form 3-lettered word. So in that case, this word ABC, this will be different from the word BCA, which will be different from the word CAB, and so on. So all these are different word. Okay, these are meaningless word, but these are different word. So word formation or number formation, for example, suppose some digits are given, say these are the 5 digits 1, 2, 3, 4, 5, and the question is how many 3-digit number are possible using these 5 digits. So one of the numbers that you can think of is 1, 2, 3, another number is 1, 3, 2, and you can see that these two are different numbers. Okay, so here the order in which we are doing the selection, that is that will be a different case. Okay, so that we have to also consider. But in case of combination, this order is not important. So in case of permutation, order is important. So word formation, number formation, these are the examples of permutation. But in case of combination, the order is not important. Let me write that thing here. In case of combination, order is not important. So this means if some points are given and we have to form triangle or a straight line or quadrilateral, or suppose if we have to select a team from a given number of players. So those will be the example of combination. So this is very basic difference between permutation and combination. You have to use NPR when order is important. You have to use NCR when order is not important. Okay, so our next question is, there are 10 points in a plane, no 3 of which are collinear except for 4 points. So this means there are 4 points which are collinear, and out of remaining 6 points, no 3 are collinear. Now the question is, find the number of, first part is a straight line, second part is triangle, and third part of the problem is quadrilaterals that can be formed using these 10 points. So first let me draw the figure. See, there are total 10 points, and out of those 10 points, 4 are collinear points. So I am going to draw a semicircle, and on diameter I will take the collinear points. Say these are the 4 collinear points, 1, 2, 3, 4, and on semicircle I will take non-collinear points. So say these are the non-collinear points, 1, 2, 3, 4, 5, 6. Now see, there are 2 reasons. One reason is this, reason 1, which has 6 non-collinear points, and the second reason is reason 2, which has 4 collinear points. Now the question is, by joining these 10 points, how many different straight lines is possible? So see, we can get, for a straight line we need 2 points. Now 2 points can be selected in a number of different ways. You can select 2 points from reason 1, or you can select 1 point from reason 1 and 1 point from reason 2, or you can select 2 points from reason 2. Okay, so if I select any 2 out of these 6 points, then I will get one straight line. So the number of straight lines, this will be 6C2. 6C2 means select any 2 out of these 6 points, and corresponding to each selection you will get one straight line. Now the second possibility is that we can select 1 point out of these 6 points and 1 point from these 4 points, and in that case also we'll get one straight line. So the number of straight lines in this case will be 6C1. I'm selecting any 1 out of these 6 points, so that can be done in 6C1 number of ways, into 4C1. So this will be the number of a straight line which are formed by taking 1 point from reason 1 and 1 point from reason 2. And finally, if I select any 2 out of these 4 points, then in that case I will get only one line. See, there is difference between line and line segment. Okay, line, this is line segment. Line segment will have a fixed starting point and end point, but a line is extending in both direction up to infinity. So this will mean that the line 1, 2 is same as line 1, 3 is same as line 1, 4, and so on. So if I select any 2 out of these 4 points, then in that case I will get only one line. So the number of straight lines which we will get after selecting any 2 out of these 4 points, this will be simply 1. So 6C2, any 2 out of these 6 points, plus 6C1 into 4C1, 1 from reason 1 and 1 from reason 2, and one line by joining any 2 out of these 4 points. So this will be the number of a straight line. The second one is number of triangles. Now see, for triangles we need 3 points. Now these 3 points can be selected in a number of different ways. You can select 3 from here, or 2 from here, 1 from here, or 1, 2, or 0, 3. Okay, so if I select any 3 out of these 6 points, then I will get one triangle. So this will be 6C3, plus if I select any 2 out of these 6 and 1 from these 4 collinear points, then also I will get a triangle. So this will be 6C2 into 4C1, plus if I select 1 out of these 6 non-collinear points and 2 from these 4 collinear points, then in that case I will get one triangle. So this will be 6C1 into 4C2, plus now if I select all the 3 points from these 4 collinear points, then in that case I will not get any triangle. So this means if I select any 3 out of these 4, I will get 0 triangle. So this will be the number of triangles. And finally, number of quadrilaterals. So for quadrilaterals we need 4 different points. Now that can be done in a number of different ways. You can select 4 from here, 0 from here, or 3, 1, or 2, 2, or 1, 3, or 0, 4. So we are going to see how many quadrilaterals we are going to get in each one of those cases. So if I select any 4 out of these 6 points, I will get 6C4 number of quadrilaterals. Now the next possibility is that I am selecting 3 from here and 1 from here. So this will be 6C3 into 4C1. Or we can do that we can select 2 from these 6 collinear non-collinear point and 2 from these 4 collinear point. So this will be 6C2 into 4C2 plus, now see, if I select 1 from the here and 3 point from here, then in that case I will not get any quadrilateral. Suppose if I'm selecting say point 4 and 3 points are 1, 2 and 3, so in this case you can easily see that I will get one triangle, I will not get any quadrilateral. So this means here I will get 0 quadrilateral, and if I select all 4 out of these 4 points, then in that case also I will not get any quadrilateral. So this will be the number of quadrilaterals. Now there is another approach to solve these type of problem. The second method is the number of straight lines. This will be, first we are going to count how many lines were possible if all the 10 points were non-collinear. So see, if all 10 points are non-collinear, then by joining any 2 points we'll get one straight line. So this means the number of straight lines in this case will be 10C2 minus, now because these 4 points are collinear, we lost some lines. Okay, line 1, 2, 1, 3, which would have been different if all the 10 points were collinear, is now same. So see here how many different lines were possible if I select any 2 out of these 4, 4C2, and how many lines here we are actually getting only 1. So this means we lost 4C2 minus 1 number of lines. So this means the number of straight lines will be 10C2 minus 4C2 minus 1. 10C2 is the total number of lines if all the 10 points are non-collinear, but because those 4 points are collinear, we lost 4C2 minus 1 number of lines. So therefore if I subtract 4C2 minus 1 from 10C2, I will get the number of lines which are actually forming here. Similarly, in case of triangles also you can think that number of triangles will be, see, if all 10 points are non-collinear, then number of triangles will be 10C3. If I select any 3 out of these out of those 10 points, then I will get one triangle. Now because these 4 points are collinear, I am not getting any triangle here. Okay, in the last case we are getting 0 number of triangle. So if I subtract this 4C3 from 10C3, then in that case I will get the actual number of triangles which are forming. And finally, about the number of quadrilaterals, if all 10 points are collinear, then the number of quadrilateral that is possible is 10C4. If all 10 points are non-collinear, then 10C4 number of quadrilateral is possible. Now because these 4 points are collinear, we are not getting any quadrilateral in last 2 cases. So if I subtract the last 2 cases from 10C4, then I will get the number of quadrilaterals. So this will be 10C4 minus, see, in the second last case we are not getting the quadrilateral. Now this case was 3 from 4 collinear point and 1 from these 6 non-collinear point. So this will be 6C1 into 4C3, this was the second last case, minus, if I select all 4 out of these 4 collinear point, then in that case also I will not get any quadrilateral, so minus 4C4. So this will be the number of quadrilaterals. So you can solve these type of problem using any one of these 2 methods. I prefer method 2 because in this second method you have to do less number of calculation. You have to only, for example, in case of number of triangles, if you are solving using method 1, then you have to calculate all these terms. But if you are solving using method 2, then you have to find only 10C3 minus 4C3. So this was a very interesting problem. After this we will start probability. Okay, so now we are going to start this chapter probability. Till now we have discussed some of the basic concepts of permutation and combination. So in probability we'll start with some terminology. So the first term is sample space. Now the sample space is defined as that it is the set of all possible outcomes in a random experiment. See, in probability we talk about random experiment. Random experiment means those experiment whose outcome is not fixed. Okay, if the outcome of an experiment is unpredictable, if outcome is unpredictable, then in that case we say that the experiment is random experiment. So sample space is nothing but set of all possible outcomes in a random experiment. So we can consider some of the example. For example, if we are tossing a coin, then in that case only 2 possibilities, either will get head or tail. So this means here the sample space will be this set of head tail. These are the only 2 possibilities. Similarly, if we are tossing 2 coins, then total 4 possibilities there. We can get head on both coin, or head on first, tail on second, or tail on first, head on second, or tail on both coin. So these are the 4 possibility if we are tossing 2 coins, and therefore the sample space will be this set: head head, head tail, tail head, or tail tail. In order to write sample space, you can also write this sample space using the concept of tree diagram. For example, if we are tossing 2 coins, So there are two possibility, head or tail on first coin, and corresponding to each possibility you will have two possibility on the second coin. So this means here your sample space will be head head, head tail, then tail head, tail tail. So using tree diagram also you can write the sample space. And another example that we can think of is throwing of a dice. So in this case the sample space will be, now total 6 possibilities there, you can get any one of these 6 numbers, and therefore in this case the sample space will be this set of numbers 1, 2, 3, 4, 5, 6. Now next term related with probability is event. Now this event is nothing but subset of sample space. Event is subset of sample space. So for example, if we are say throwing a dice, so in that case we have seen, if we are throwing a dice, then in that case we have seen that the sample space will be the set of these 6 numbers 1, 2, 3, 4, 5, 6. Now any subset of this set, this will be an event. So we can define an event, say outcome is odd number, so we can call this event as say E1. Now this event E1 will be, outcome will be odd number if I get the numbers 1, 3 or 5. So this means event E1 will be set of 1, 3, 5. In a similar manner you can define many other subset, and each subset will be an event. So for example you can think of say even prime number, say outcome is even prime number. So this means our event E2, which is representing that the outcome is even prime number. Now only even prime number is this number 2. So this means event E2 is 2. So in this way you can think of many other event. So these are two very basic terms. Sample space means set of all possible outcome. Event means simply subset of sample space. Now one more important thing. Suppose if I have say in NS is the number of element. Say NS is number of elements in sample space. Say NS is number of element in sample space. For example, if we are throwing a dice, then in that case total 6 possibility are there. So this means NS will be 6. So in that case the number of event will be, number of event is nothing but number of subset. Now this is a very standard formula which you have to remember. If NS is the number of element in sample space, then in that case number of event will be simply 2 to the power NS. Okay. This is a very standard formula. Number of subset of any given set is 2 to the power number of element in that set. So if a set has NS number of element, then in that case number of subset will be 2 to the power NS, and this subset is nothing but event. So these are the two basic terms. Now we can define probability. So after this we'll see what is the definition of probability. Okay, so now we are in a position to define probability. So the definition of probability is that if a random experiment means outcome is not predictable. So if a random experiment results in n mutually exclusive means if intersection of two events is phi, if nothing is common between two events, then those two events are called mutually exclusive. So for example, if we are tossing a coin, then head and tail are mutually exclusive events, because either you can get head or you can get tail. So if a random experiment results in n mutually exclusive, equally likely, if chances of all the events are same, then those events are called equally likely events. So if a random experiment results in n mutually exclusive and equally likely events, out of which m is favorable to an event E, then in that case the probability of this event E, this will be simply m by n. M is number of elements in event E, and this divided by number of element in sample space S. Okay, so this thing you can also write as number of favorable cases, and this divided by total number of cases. So this will be the definition of probability, number of favorable cases by total number of cases. Now there are some important points related with probability which you should know. The first point is, if PE is the probability of any event, okay, we can write this in this manner, PE is the probability of event E. So we know that this number is always between 0 and 1. The maximum value of probability of any event will be 0 and the minimum value is 1. Now if probability of any event is 0, then that event is called impossible event. If probability is 0, then it means the event is impossible event. And if probability of any event E is 1, then that event will be sure event. So this is first point. Probability of E is a number between 0 and 1. If it is 0, then the event is impossible event. If it is 1, then the event is sure event. Now the second point is probability of any event E plus probability of E complement. E complement means probability of not happening of E. So probability of E plus probability of E complement, this will be 1. So this means you can write probability of E complement as 1 minus probability of E. Now again, this is a very important formula. If you know the probability of any event E, then you can find probability of E complement and vice versa. And the third and most important point is odd in favor of an event. Sometimes probability is also represented in this manner, odd in favor of E. So the definition of odd in favor is that odd in favor of an event E, this will be number of favorable cases, and this divided by number of unfavorable cases. So definition of probability was number of favorable cases by total number of cases. Odd in favor of event E, this will be simply number of favorable cases, this divided by number of unfavorable cases. And similarly, odd against an event, odd against E, this will be simply 1 by odd in favor of E. Odd in favor of E. Now from odd in favor and odd against, you should know how to write the probability. So for example, say it is given that odd in favor of E is say 2:5. So this means 2 is the number of favorable cases and 5 is the number of unfavorable cases. So if you want to write probability of this event E, so this probability of event E you can write, see 2 is the number of favorable cases and 5 is the number of unfavorable cases. So this means total number of cases will be 2 plus 5, 7. So probability of event E, this will be simply 2 by 7. 2 is number of favorable cases and 7 is the total number of cases. So once odd in favor or odd against an event is given, then you should know how to convert that in terms of probability. So these are the three basic points that you have to remember in case of probability. First one, probability is always between 0 and 1. Second, probability of E plus E complement is 1. And the last point, odd in favor of E is number of favorable cases, this divided by number of unfavorable cases. Okay, so our first question is, a fair dice is rolled twice. The probability that outcome in second throw is more than the outcome in first is. This question was asked in GATE 2013. So this is a very simple problem. Now there are a number of ways to solve this problem. The first one is very basic approach, that write all the possible outcome. So if we are throwing two dice, then this will be your sample space. The outcome on first is this is your sample space 1 1 1 2 1 3 up to 1 6. Similarly, if the outcome in second throw is 1, then again you will have 6 possible outcome on second throw. So you can easily see that the number of element in sample space here will be, there are 6 possible outcome for the first throw and 6 possible outcome for the second throw. So this means if we are throwing two dice, then in that case total possible outcome is 36. Now we have to see what are the favorable outcome. So the question is, the outcome in second throw has to be greater than the outcome in first throw. So this means if the outcome on first throw is 1, then these are the possible outcome on second throw. So these are the 5 favorable cases when the outcome on first throw is 1. Similarly, when the outcome on first throw is 2, then you can easily see that these are the favorable cases. So in this way, when the outcome on next throw is outcome on first dice is 1, so in that case again you will have 3 favorable cases and so on. So this means number of favorable cases NE, 5 when outcome on first is 1, then 4 when outcome on first throw is 2, similarly 3 plus 2 plus 1. Now if you add all these numbers, you will get 15. So total there are 15 favorable cases and total number of cases is 36. So this means probability of this event E, this will be simply NE by NS, which is 15 by 36. Now you can further simplify this, but this will be our answer. Probability that outcome on second throw is more than outcome on first throw, this will be simply 15 by 36. Now there is another approach to find this number of favorable outcome in E. Okay, so we are going to see what should be the smarter approach to find the number of favorable cases. So see, if we are throwing a dice, then in that case the total possible outcome on first throw is 1 2 3 4 5 6. These are the 6 possibilities. Now the question is, outcome on second throw has to be the outcome has to be more than the outcome on first throw. Now if I select any two out of these 6 numbers, okay, how many ways are there to select 2 out of these 6? This will be simply 6C2. So, and if I select any 2 out of these 6 numbers, then that will give you one favorable outcome. Suppose if our selection is the number say 2, 4. So this means this will give you the favorable outcome 2, 4. Even if the selection is 4, 2, the corresponding favorable outcome will be 2, 4. So the number of favorable cases, this you can easily find. This will be simply 6C2. You don't have to do all these calculations. You can directly write this as 6C2. And if you do the calculation, 6C2 will be factorial 6 by factorial 2 into factorial 4. And after simplification, you will get 15. So this is another way to find the number of favorable cases. Suppose the question is that outcome on second throw is more than outcome on first. If a die is thrown 3 times and outcome on second is more than outcome on first, and outcome on third is more than outcome on second, so in that case you cannot solve using this approach. So there you can directly write that the number of favorable cases will be simply 6C3. Okay, so this was a very basic problem. Now the next question is, 3 vertices of a regular hexagon are selected at random. The question is, find the probability of getting an equilateral triangle. So first we are going to draw a regular hexagon, and then we'll see how to find how to draw an equilateral triangle. So suppose this is our regular hexagon. There are 6 sides. Regular hexagon means all the sides are equal. So say these are the 6 sides, A, B, C, D, E and F. These are the 6 vertices. Now first we have to find how many different triangles are possible. So number of elements in sample space, this will be simply the number of triangles. So total there are 6 points, and for triangle we have to select any 3 out of these 6 points, and corresponding to each selection will get one triangle. So this means number of possible triangle, which is the number of element in sample space, this will be simply 6C3. 6C3 is 20. So total 20 triangles are possible. Now the question is, we have to find the probability of getting an equilateral triangle. So see, if we can get an equilateral triangle if we select the point A, C and E. If I select these 3 points, then you can easily see that this will be one equilateral triangle, because all the sides are of equal length. So if I select alternate vertices A, C and E, then I will get one equilateral triangle. And another equilateral triangle that you can see is B, D and F. Okay, so there are 2 equilateral triangle. One is ACE and another is BDF. These are the 2 equilateral triangles. Now the question is, we have to find the probability of getting an equilateral triangle. So you can see that there are 2 favorable cases and total number of cases is 20. So this means probability of getting an equilateral triangle, this will be NE by NS. Now NE is 2, NS is 20, so this will be simply 1 by 10. Okay, so this was a very simple question. Only thing is that you have to see how to get an equilateral triangle. So if I select alternate vertices, then in that case I will get an equilateral triangle in case of a regular hexagon. Okay, so our next question is, a committee of 4 is to be formed from 4 girls and 5 boys. Find the probability that committee will have less number of boys than girls. This question was asked in engineering services this year in 2019. So this is a very simple problem. First we have to find the number of element in sample space. Number of element in sample space, this will simply mean number of ways to form a committee of 4 persons out of these 9 persons, 4 girls and 5 boys. So the number of ways to form committee of 4 persons out of these 9 persons, this will be simply 9C4. Here we have to do selection. Okay, team formation are examples of selection. So here only we have to select 4 out of these 9 persons, which can be done in 9C4 ways. Now the next part of the problem is, we have to find that out of these 9C4 number of committees, in how many committees there are less number of boys than number of girls. So for these type of problem, you should always make a table. On one side you should write number of boys, number of girls and number of ways to form committee. Number of ways to form committee. Now there are number of possibilities for this. The first possibility is that you can select, total there are 4 girls and there are 5 boys, and we have to form a committee of 4 persons. So one possibility is that you can select all girls and 0 boys. So 4 girls are selected, 0 number of boys are selected, and the number of ways of doing this selection, this will be, we have to select 0 out of 5, so 5C0, and we have to select 4 out of 4, so this will be 4C4, and we have to use the multiplication rule here because the work is completed in 2 steps. Now the next one is we can select 3 girls and 1 boys, and in that case also the number of girls will be more than the number of boys. Now 1 boy out of 5 can be selected in 5C one number of ways, and then we have to select 3 girls out of 4 girls, so this can be done in 4C3 number of ways. And there is no other possibility, because if I select 2 girls and 2 boys, then in that case we'll have equal number of boys and girls. The question is how many of those committees will have less number of boys than girls. So this means the number of girls has to be more than the number of boys. So there are only 2 cases, 4 girls 0 boys or 3 girls 1 boy. Now in the first case 5C0 will be 1, 4C1 is 1, 1 into 1 will be 1, 5C1 will be 5, 4C3 will be 4. So if you multiply this, you will get 5 into 4, 20. So this means number of favorable cases NE, this will be 20 plus 1, which is 21. So total number of cases is 9C4, number of favorable cases is 21. So this means probability of this event E, this will be 21, and this divided by 9C4. Now after this you have to do calculation only. 21, this divided by 9C4 you can write as 9 into 8 into 7 into 6 into 5 factorial, and this multiplied by will get 4 factorial in numerator and 5 factorial. So 5 factorial, 4 factorial you can write as 4 into 3 into 2. These 2 will cancel. 4 into 2 is 8. Then 7. This will be 3. 3 into 3 is 9. So finally after calculation you will get 1 by 6. Your answer is 21 by 9C4, and after simplification you will get 1 by 6. So the correct answer for this question is option D. The probability that number of girls is more than the number of boys will be simply 1 by 6. So as you can see, this was very simple problem. Only thing is that you have to form this table, and from table you have to see what are the possibilities. Now the next question is, this was asked in GATE 2015 in computer science and electrical engineering. The question is, 2 sets are given. One set is 2, 3, 4, 5, and another set B is 11, 12, 13, 14, 15, and 2 numbers are randomly selected, one from each set. So this means one number is selected from set A and another number is selected from set B. Now the question is, find the probability that their sum is 16. So again here first we have to find the number of element in sample space. So number of element in sample space will be number of ways of selecting 2 numbers, one from set A and another from set B. So one element can be selected from set A in 4C one number of ways. Total 4 elements are there, you can select any one of these 4. So this can be done in 4C one number of ways. And one element we have to select from set B. So this can be done in 5C one number of ways, because total 5 elements are there in set B and we have to select any one out of those 5. So 4C1 will be 4, 5C1 is 5, 5 into 4 is 20. So total 20 possible way is there to select 2 numbers, one from set A, one from set B. Now the question is, what is the probability that their sum will be 16? So now we have to see what are the favorable cases. So if I select 2 from set A and 14 from set B, then in that case the sum of these 2 numbers will be 16. So one favorable case is 214. Similarly, the other favorable cases that you can say is 313, then 412, and finally 511. Okay, for these 4 outcomes, the sum of 2 numbers will be 16. So this means number of favorable cases is 4. Total number of cases are 20, out of which 4 is the number of favorable cases. So this means the probability that sum of the 2 numbers will be 16. This will be simply number of favorable cases, this divided by total number of cases. So this will be 4 by 20. 4 by 20 will mean 2 by 10, which is 0.2. So the correct answer for this question is option A. After this, we will see addition theorem of probability. Hello. Done. Yeah.